Hi, in this lecture video, we are going to discuss about one of my paperwork, which have focused on the fabrication of novel scaffold containing polyurethane and grapes for wound healing. The abstract of my study was in this study, I have utilized the electrospin technique for fabricating these scaffolds. It was confirmed from the my study that my fabricated novel composites based on the PU containing grapes showed better physiochemical properties that can be suitable for the wound dressing applications. First, we'll discuss about what is wound dressings. Wound dressings play important role in managing many types of wounds, such as traumatic, thermal, and chronic wounds. For wound dressings, the traditional wound dressing used were biological, synthetic, and biological synthetic. However, they possess some drawbacks, such as limited supplies, high antigenicity, poor adhesiveness, and the risk of cross contaminations because of using alloy skin and pig skin. Hence, there is a need for alternate approach for developing a new wood dressings. Uh, Next, we will discuss electrospin technique. Yeah, ideal wound dressings possess certain properties such as moist environments, allowing gases exchange, and further and another properties such as it should fight against microorganisms. To attain these characteristics, we want to develop a suitable scaffold. So I have used the electrospin technique for fabricating this scaffold. Why I use electrospin technique means it is a versatile and cost-effective technique. Further, we can produce nanofibers from the polymers. Uh, the nanofibers possess high surface area volume and porous structure, which help the cell adhesion and proliferation for the new tissue growth. Next, I used polyurethane for my research. Why I use polyurethane means it is commonly easily available polymer, and it can be easily processed in any organic solvents. Next, I utilized the grape extract for my study. Why I used means it contains various bioactive constituents such as sugars, organic constants, phenolic compounds, and aromatic compounds, minerals, and peptic substance. Further, it also concluded literature, the bioactive constituents in the grapes possess antioxidants, anti-cancer, antimicrobial, anti-inflammation study. So I used grape in my study. First, for electrospinning, we have to prepare the solutions. The P was prepared for 9-weight fractions. Similarly, grapes also prepared for 9 weights. In terms of volume fraction, we are usually 8:1 ratio based on the literature. After the solution was fabricated, it was transferred to the electrospinning, and finally the scaffold will be fabricated. After fabrication, it was sent to various specific captions such as FTR analysis, quantitative measurements, thermogravimetry analysis, and atomic force microscopy. And the symbols used to study the fiber morphology of the scaffolds. The PU showed the diameter of 890. However, grapes showed reduced fiber diameter of 730. It was clearly showed in the literature that the smaller diameter of the nanocomposite will be suitable for the fibrous cell application and proliferation. Next, FTR analysis. FTR analysis used to confirm whether we added the grapes or not. In the figure, the blue indicates the PU. It was shown in the figure that the PU grape showed greater intensity compared to the PU, which clearly indicates the presence of grape in the PU membrane. Color angle measurement is one of the important parameters in the biomedical applications. And the PU showed the color angle of 100. PU grape showed color angle of 86, which clearly indicates the hydrophilic nature. which can be suitable for the fibril cell adhesion and proliferation. Uh, the corresponding TJ curve was shown in the figure. The blue line indicates the PU grapes. The red line indicates the PU grapes, which clearly indicates the initial on-gradation temperature was increased compared to the PU, which clearly indicates the addition of grapes improved the thermal stability of the PU. And finally, surface roughness. Surface roughness was used to predict whether the surface is smooth or not. The PU membrane showed the surface roughness 313. However, PU grapes showed the surface roughness 469 nm respectively, which clearly indicates that the surface of the PU grapes was smooth compared to the PU. It was clearly showed in the literature that the improved surface roughness of the compost will be suitable for the fibril cell adhesion and proliferation. The corresponding image was shown. The PU was smooth. However, the PU grape showed some up and downs, which clearly indicates the smoother surface compared to the PU. Thank you.